Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, let's continue our C programming language tutorials. In this video, we're gonna continue our tutorials. We're gonna focus on the data type. The data types really is a very interesting topic. Why? Because you should understand, or you must understand the data types you use in C, because it really affects, or they really affect the program you write, and it is related to the memory, random memory we have on the PC or on the machine. For example, if you deal with high precision, or the problems that require very high precision in the solution, or you want a very high precision or accuracy solution, you have to carefully select the data type that's perfectly suitable for the problem. For example, for computational fluid dynamics problems, CFD, sometimes we deal with very simple problems that we only need single precision. But sometimes, and the majority of time, we use very complex, or we face very complex problems or mechanical problems for the fluid dynamics or heat transfer. So we need to use the high precision or the double precision. So you are now the coder or the programmer, so we have to know the data types to optimize our code. Sometimes we do not know the suitable data type for our problem, so we wrongly select the type, and this requires higher memory, and we do not have it, and we do not need to use this high accuracy. So let's get started. So we have here data type from the book tutorials points. I showed you the previous tutorial. So data types in C refer to an extensive system is used for declaring variables or functions of different types. The type of a variable determines how much space it occupies in storage and how the bit pattern stored is interpreted. So the types in C can be classified as follows: types and description. Basic types we have they are arithmetic types, and are further classified into integer types and floating point types. Enumerated types, they are again arithmetic types, and they are used to define variables that can only assign certain discrete integer values throughout the program. The type void, the type specifier void, indicates that no value is available, does not deal with variables. Derived types, they include pointer types, array types, structure types, union types, and function types. We're gonna cover these things, but we're gonna focus on the integer and floating now. So the array types and structure types are referred collectively as the aggregate types. The type of a function specifies the type of the function's return value. We will see the basic types in the following section, whereas other types will be covered in the upcoming chapters. Okay. So we have integer types, and also you can get these things from the online websites for further information. The following table provides details. Okay, the standards. We have a char, unsigned char, signed char, int, unsigned int, short, unsigned short, long, unsigned long. So we have here is storage size 1 byte. Only you need just 1 byte from the RAM, and here the values range -1 to 8 to 1 to 7, or from 0 to 255. Unsigned char 1 byte to 0 to 55, signed, and so on. Here are the ranges and the storage size. Okay. So as you can see, storage size is changed from type to type, and you have to know what is the better type for our code. Okay, so as you can see here, if we deal with long numbers, or if your code solves or deals with high accuracy, we use long. And as you can see, this is the range. And unsigned long, it only uses or deals with the positive numbers. As you can see, the unsigned short and short, the short from negative to positive, but here is from 0 to 65535. This means the unsigned short, unsigned long only deals from 0 to positive, no negative. Unsigned end from 0 to positive, from 0 to positive. And inside char and unsigned char from 0 to positive. This is the meaning of unsigned. Okay, it means that there is no sign of the sign, I guess the negative sign, I guess. Okay, so let's see. So this code, so let's start, let's open our tutorial. So when we deal with long numbers, you can use long, and if you do not have to use high accuracy, you can use short. Here's hello world. Okay, so this here, integer, floating point, character string, boolean. I got this PDF from Google, you can get it. So integer, a whole number, a number that has no fractional part. The following are integers: 0, 1, minus 1 to 5, and this long number, but this is not float. Because the following are not integers: 5.34 minus 1.0, 1.3 to the power 4. Okay, so this is called this, I guess, string. Where? So there are often different sizes of integers available. For example, PCs support short integers, which are 2 bytes, and long integers, which are 4 bytes. It depends on the PC. Floating points, a number with a decimal point. The following are floating point numbers: 3.0, minus 1, 1.5. Floating point representations are slower and less accurate than fixed point representations, but they can handle a larger range of numbers. It requires more space. Why? Because it will increase the accuracy. So character here, in graphics-based applications, the term character is generally reserved for letters, character, numbers, and punctuation. It only can represent single character. The following are characters: A or capital, at, dollar sign, and 2. So here, as you can see, the floating point representations are slower and less accurate than the fixed points, but they can handle a large range of numbers. So to require more space, but not because, I'm sorry, I told you it's more accurate. No, because it has to handle a larger range of numbers. Okay. Okay, let's continue. Here the string. String is a sequence of character. So we have here a character, just one symbol, but here we have strings. We're gonna cover, I guess, the string on the next tutorial in detail. So we have example, the names like this, or sentences. Boolean deals only with true false. 2 possible values use this type for simple flags that track true false conditions. Okay, we have a declaration. Programming languages, all variables that a program is gonna use must be declared prior to use. Declaration of a variable serves two purposes. It associates a type and identifier or name with the variable. The type allows the compiler to interpret statements correctly. It allows the compiler to decide how much storage space to allocate for storage of the value associated with the identifier, and to assign an address for each variable, which can be used to encode generation. This means that here I have declaration, a typical set of variables declarations that might appear at the beginning of a program could be as follows: data type or variable. So let's see. So I have here int count. Often programming numerical constants are used like this. We have to tell the user that pi is 3.14. So this is a declaration. It's worthwhile to associate meaningful names with constants. Pi equal 3.14. If you know tau or another constant, you declare it at the beginning. These names can be associated with the appropriate numerical values in a constant declaration. So this is the constant. The names given to constant must conform to the rules for the formation of identifiers as defined above. So the way to declare something here is constant int days in year is 365. 365 is an integer. And we have here the declaration to tell the user that 365, what is it? What I'm gonna do with it. So it's constant integer days in a year. Okay, so now I know. So this is the general form. You put the constant, and here's the type constant identifier. Put what you want, and here is its value. Okay, so again, here we have a simple code to know the size, exactly the size of these things on your PC. So if we copy this, let's put H. Okay, we can copy it, all of it. Not easy to copy these lines. Okay, I just wanna get this because it is very important. System and return. Okay, and we have here stream node.h. Okay, so now we can get the size of integer on this PC. Source, so build, start. Okay, we don't have any errors. So storage size for int is 4. So let's check. Int is 2 or 4. In my PC, it's 4 bytes. So it's not 2. So here is the answer. Storage size is 4. So the executor produces the following result on Linux. Or here I have Windows. So if you wanna get another type short, for example, oh, sorry, I did not cancel this. Yes. So short is 2. Why? Because the number is short, 2 bytes. Let's see long. So long is 4. So as you can see, long is the double of short. We can see also unsigned short. From 0 to positive, it's 2. So short or unsigned short are 2 bytes. 2 bytes, okay? Or here 2 or 4, and so long and so on. You can get what you want. Okay. For floating points, we have here float. We have 4 bytes. As you can see, float 4 bytes. Int 2 or 4, and short 2 bytes. Unassigned short is 2 bytes. So if you use short numbers or unassigned short for your code, it takes or it requires less memory. So this is the difference. You should know or what is the suitable for the program. If you don't have to deal with high accuracy, no need to use float. Okay. So here is float, double, long, double. So let's see float. Size of float is 4. So size of double, let's see double. Float is 4, double is, I guess, it will be 8. Yes, it's double. And long double here is 10 bytes. Let's see. What? Long double. Go ahead. The PDF shows it's 10. Let's see here. Oh, it's 8. So I have here 8. So double, and here is it's exactly like long double for my PC. Okay, let's see what does this mean. Also, you can get this code to know the size. So storage size float 4 and minimum float positive value and negative value precision value is 6 digits, I guess. We can use this code. Let's copy it. Always leave system pulse because it was gonna be a problem for my PC. Let's see, the size of float is 4 positive to negative. I'm sorry, the minimum float positive, and here is the maximum float positive, and here the precision value is 6. Okay, so this is the exactly what we have. So let's get more. So we have here a code. So let's include. There's not limits. Okay, libraries to the library. I guess we int min void. What's floating point type usage in C, floating point types. Now we're gonna compare between the floating numbers. Okay, we have a float double and long double. Float double and long double. Let's see if I deal with a program or a situation, what is the best for me now? Float double or long double? Okay, let's see. So we have here to put these things. Here I have to declare floating point types. Float is float number, double, and here long double. Okay. If we do not do this, the code will not identify them. Okay. So here is the size of floating point types. It's exactly the size of, exactly like what we have just done to know the size. So let's see storage size. Oh, we have here a problem. So let's continue. So gentlemen, again, I deleted this. Just I wanna get the size. I only need these lines. So it's again, do it again. Printf. I wanna the size of. Yeah. So we have here the floating unsigned float for the double is 8 and the size for long is 8. So okay, now these are the sizes. So now I'm gonna make an example. This example I got it from an example or video online, but it is in Arabic, not in English. So float number, we're gonna divide 3 by 5. 3 by 5, if you use your calculator, you will get 0.6. So let's see what is the difference between these results if I use float or double number or long double. So puts in compare precision for decimal. Let's see this. Here is 4 decimal. Okay. And let's take it. It's 1.4, 4 digits after the 0. So here is 0.6000. It's here is 4 decimal points after the 0. Here is compare precision at 4 decimal points. Here is the line percentage 1.4. Okay, and so on. F and LF for the double, and long double is L capital. Oops, this is L capital for long double number. So 3 divided by 5 gives what? 0.6, but here we have 0, 0, 0, and as you can see, they are the same. So if you deal with a problem that does not require high accuracy, you can use float number. No need to use double number or long double number. Why? Because 4 bytes is better than 8 bytes. It will get, or it requires higher memory. Okay, so you can save your the memory you have by using float number. No need to use double because it is the same result. Okay, it will not differ. So here is the optimum choice is 4 bytes is float number. Okay, awesome. So let's get the other test, the second test. What if we use 20 decimal? So here, got no errors. Oh god, we got here float number is 0.60, many zeros, and this number. And we have here double number is 0.5999, lots of nines. And as you can see, there are big differences between the float number and double number and long double number. We have here float number cannot handle 20 decimal points. It is larger than what it can take. So if you deal with high accuracy projects, or you have to get the exact solution, you should not use float number. 20 decimal cannot be good. So now we have to choose between double number and long double number. As you can see, they are exactly the same. They are exactly 0.5999. As you can see, no changes. So we have here 8 bytes, 8 bytes. I guess it is double number is the choice, because for me here, I guess if I use this or this, it doesn't matter, I guess, but you use the double number if your storage size for long double is higher than 8 bytes. As you can see in the PDF, it writes here 10. This may be your case, so of course you should use the double number. Okay, so let's get the other test. What if I deal with very, very, very high accuracy projects? We have here 60 is 1.60 LF, capital and small, and here is F. So let's run it. So no errors. So we have here compare precision 6 decimal. Okay, we have 0.6 zeros and these numbers, and it cannot handle anymore. No way. We have here the double number, as you can see, is 5 nines and 7s and 9 5, and as you can see, it is, we have here the double and long number. I guess they are exactly the same. So what if, like I said, if here the storage size for long double is 10 bytes or 16 bytes, of course, if this is the same or similar to the double is similar to the long double, of course you have to choose double number if you deal with very high accuracy. For example, the biology calculations, the mathematical calculations that related to scientific research or computational fluid dynamics for mechanical engineers. But if you deal with very simple calculations like just add and subtract or multiplications at a bank or at a supermarket, of course you no need to use double numbers or long double numbers. You just use the float. You only use 4 decimal or 6 points, and this is the deal. So we have here to know, for example, the machine you use for bytes or the storage in your machine. Okay, because this completely differs from machine to machine. I have here the double is exactly like long double, so of course I will use the double if I need to use the high precision. This reminds me of ANSYS Fluent double precision. We have to choose, yeah, before we enter the ANSYS Fluent software, I have here options, double precision, or I have to use single precision. If I want to use single precision, no need to check this mark. If I deal with very complex situations or problems like turbo machinery, I have to use double precision because this will increase the digits. Okay, it will increase the digits and it reaches the conversions better or easily. Of course, you have your serial and parallel. If you use simple problems like flow around the cylinder and these kind of things, or flat plate, you use serial because no need to use the all threads you have. Only one thread will be enough. But parallel, if we deal with high or direct turbo machinery, it requires more effort, so we can use parallel. We can use more than one thread at a time to solve the same problem. Okay, so that's it to this tutorial. As you can see, we got lots of information. I guess the next tutorial we're gonna complete, guess we will cover the void, and maybe we can get also the variables, or we can let the variables, because we have examples can deal with. So thank you very much. We're gonna cover the other topics next tutorial, the void type, and we're gonna see what is next. Thank you very much. Please practice and get other information from the websites here. If you can unsigned character or int, float or double, unsigned int C data type. If you wanna additional information, types int types. Okay, and there's some other. Yeah, here is the same PDF we have. Unsigned int. Signed versus unsigned. So unsigned variable type, an unsigned variable type of int can hold 0 and positive numbers, and a signed int holds negative 0 and positive numbers, and so on. You can get lots of information from these websites. So thank you very much. See you next tutorial. Wassalamu alaikum warahmatullahi wabarakatuh.